Greetings, Earthlings and creatures of the world. Alright, today's video is going to be tricky algebra, substitution. We're going to continue substitution, converting repeating decimals to fractions. This is part 2 in the substitution series. So first thing, let's start with a motivating question. So why is 0.3 with a bar equal to 1/3? There's kind of two bad reasons. So one might be, well, my teacher said so. And another reason might be, well, if you divide 1 by 3 and actually do the division, you're going to get a bunch of 3s, and so you could pretty much predict it's going to be the same pattern over and over. So going in this direction, where you're going from the 1/3, you can figure out that it should be 0.3 with a bar. But my question is, what if I gave you 0.3 with a bar and I said prove that it's the 1/3 going that way without knowing that it's already 1/3? So that's our question. All right. So a few preliminary things, and then we'll dive in. First of all, the technique for this video is very much the same as was in number 77 in this series for finite and infinite geometric series. So you might want to review that in conjunction with this. Next, how is this part different from the previous part? I mean, it's all substitution, right? There's a slight difference. So in this part, if we want to say convert 0.3 with a bar and figure out that that's 1/3, there's no equation. There's no like 5x equals 7. There's no variable. So in the previous part we were given equations, whereas here we just have expressions and we want to evaluate them in terms of fractions. So figure out what they are as fractional representations. So that's the slight distinction I would make. Alright, next. This is a bit of a fun fact. I didn't know this myself, so I only recently learned this. And I'm going to put a link in the description. So NJ Wilderberger, it's a YouTube channel, Professor Norman WIldberger. He has fantastic content. It might be a little lengthy. It might not be for the younger audience, but if you guys want to really go more in depth, and you feel free to check out a lot of his videos. He has great content. So what I learned from him and his video is if you look at some of these repeating decimals, let's say 1/7, where you get 0.142,857. Now let's say if you go through 1/7, 2/7, 3/7, if you cycle through all the sevenths, I didn't know this, but if you look at these numbers that keep appearing, they're all the same digits. And not only are they the same, but they're in the same order. It's just starting at a different point in the cycle. So let's say if we start from the 2 here, and we go 2, 8, 5, 7, 1, 4, we get that. If we start with the 4, 4, 2, 8, 5, 7, 1, we get 3/7. I thought that was pretty cool. So if you want to learn more about this, I'll include a link for you guys to check that out. One reason why might this be the case? Well, there's only so many remainders when you're dividing by 7, specifically 0 through 6. But since for these problems it's not going to go in evenly, 0 is not going to happen. So we only have 1 through 6. So that's why we would expect you to get no more than 6 digits. And in fact, this is sort of the worst case scenario. You get 1, 2, 3, 4, 5, 6 digits for all of these. If you want to learn more about this, go check out his video, see the description in this video. Alright, let's get to the meat of the matter. So this was going from fractions to decimals, so finally the heart of it, let's go from decimals to fractions. So let's say you have 0.3 and you want to figure out that that's 1/3, as we know. Alright, here's the big idea. It's going to seem really stupid, but it's a very, very powerful idea. And here is the brilliant idea. The powerful idea is, we're just going to call it something. So let's call this X. That's it. That's your brilliant idea. There's 2 brilliant ideas, but that's the first powerful idea. This may not seem like you might be thinking like, who cares, big deal. But now this allows us to treat this as an algebraic equation and work with this. So I can double it. I could say like, if I double this, I would have 2 times 0.3 with a bar. That would be 2x. So I can start working and doing stuff to this. Now here's the idea. What makes these repeating decimals ugly is that they're infinite, right? So we have this infinite ugly thing. We don't want to work with infinite things. So how do you combat one ugly thing with another ugly thing? So to kill off this infinity, the idea is we want to introduce another infinity and have them battle it out. So we don't want to just copy and paste this, because if we do that and subtract, we'll get 0 equals 0, and that's not very insightful. So the idea here is, let's try multiplying this by some special number. So maybe you want to pause and think about what the right number would be. So if you've unpaused it, let's try doing 10. what's so special about 10x is that the 10 is not going to affect this digit. All it's going to do is move the decimal point. So if you multiply 0.3333 by 10, you're just going to get 3.33333. So it just moves the decimal point 1 over. Now why is this powerful? Because now we have two ugly things, and we're going to let them battle it out. So we're going to subtract this equation minus that equation. So that's 9x on the right. And again, this is only possible because we've named it something. And the ugly part minus the ugly part is gone. So we just have the 3. So if 9x is equal to 3, divide by 9, so x is 3/9, or 1/3. So now we've proven that it's 1/3 going from the decimals. We haven't taken anybody's word for it, and we didn't start with the 1/3. So here's the technique. It's going to work for any repeating decimal. So let's just try these real quick. So let's say 0.1 with the bar. It's going to work the same way. So let's call x 0.1 with the bar. So what's 10x? 1.1 with the bar. Same technique. Subtract them. 9x is going to be 1. So x is going to be 1/9. And if you don't believe me, divide 1 by 9. So go do your long division, and you'll see you start popping out 0.1111. You keep popping out ones over here. All right, finally, let's wrap up with number 3, a little bit of a nuance, a little bit of a tricky thing. So 0.63. So now we know, let's call it a variable, and hey, let's do 10x. All right. So some of you might already be have some alarm flags, like, okay, this might not work. Why might this not work? Because this is going to create, sorry, this is with the bar. We're going to move the decimal 1 over, so we're going to get 6.36. So the 10 doesn't work this time because the ugly thing we've created does not look like the original ugly thing. It's mutated on us. So the 10 is not the right number. So we want to create a duplicate of this that's only like slightly different, but maintains this. So what should we actually multiply? So I'll let you guys pause the video and think about that. And if you're unpausing, that's right, we should do 100. Because this creates something new, yet it retains this ugly part. So we're going to keep this, but since we're moving 2 over, we're going to get 63.63 with the bar. So now we can again, if we subtract the equations, get 99x on the right, and on the left, these two uglies kill each other off, and we have 63. So to find x, divide by 99, and simplify. So if we simplify that divided by 9, you get 7. Divide this by 9, you get 11. And indeed, if you divide 7 by 11, you're going to get 0.63636363 onwards. All right. So if you guys want to practice, you can try 0.123 with a bar. All right. I'll see you guys in the next video.